So let's keep going. We're now in chapter 5, which as you can see is titled Exponential and Logarithmic Functions. Some of you may have seen this in college algebra or another course, but let's keep going. Okay, so section 5.1 is sort of a preliminary section called Composite Functions. So what we need to do is we need to understand what that means. What is a composite function? Also, once we are talking about a new way of looking at functions, we want to know what the domain of these functions is. Okay, so if you have two different functions, f and g, so here are two separate functions, f and g, you can make a new function called the composite function, which is notated like this. It's not a dot, it's an open circle, and you read f composed with g or f of g. And the definition is just the function that you do. So if I plug the number x into this composite function f composed with g, first you take x and plug it into the function g, and then you take that and you plug it into the function f. Okay. So once you have composed these two functions together, you can look at the domain of this new functions, and what you have to be able to do is you have to be able to, so if I need to do this, okay, x has to go into g, so x needs to be in the domain of g, and then once I compute g of x, that gets plugged into f, which means g of x needs to be in the domain of f, and you need both of these to be true in order for x to be in the domain of f of g. Okay, so here's a sort of picture representation of it. So we have the function g, and it's going to take an x and spit out a g of x. And in order to do the function f of g, what you do is you take x, and it gets sent over here, and now I have the number g of x, and then f takes that and does something else to it to produce this here. So to be in the domain of the overall, so overall what happened was x made this journey all the way here. And in order to do that, it had to do both steps. So x needs to be in the domain of g, and then g of x needs to be in the domain of f. So let's look at some examples so we can see exactly what's going on here. Here are two functions. F of x is 5x minus 1. G of x is 3x squared. So here are two perfectly nice functions. We could do things like graph them, find intercepts, etc. But now what we want to do is understand the composition. So find each of the following: f of g of 1, g of f of 1, because it might be different, f of negative 2. In other words, you're using f in both spots there, and then g of negative 2 as well. So pause for a moment, try to figure this out. We'll come back and do the first one in detail, and then I'll pause again in case you got that one wrong. You can try to do the others again. Okay, so in order to compute f of g of 1, the first thing you need to do is take the number 1 and plug it into g. Okay, so g of 1 is 3. So all we did is we took the function g of x, which is 3x squared. That was given way up here at the top. If you plug in 1, you get out 3. So that's g of 1. G of 1 is 3, so that's the substitution right here. And now we have f of 3, so compute f of 3 by taking 3 and plugging it into the function f. Well, f of x is 5x minus 1, so we get 5 times 3 minus 1 for a result of 14. Okay, so see how we took the number 1, we plugged it into g, we got something out, and we took that and plugged it into f. So if you got that one wrong, try b, c, and d again. So I'll pause here. Okay, so moving on. To do g of f of 1, first you take the 1 and you plug it into f. F of x, remember, was 5x minus 1, so f of 1 is 4. So you take that 4 and you plug it into g. So you do 3 times 4 squared for a final result of 48. For part C, we're doing f of negative 2. So we take negative 2 and we plug it into f, which gives us negative 11. And then I take that negative 11 and I plug it into f, and I get negative 56. There's no reason you can't do the same function composed with itself. So for part D, we were asked g of negative 2. And remember, g of x is 3x squared. So plug negative 2 in and get out 12. Then plug 12 into the same function and get out 432. So there are a couple examples of computing how a composite function works. So in the next video, this one's pretty short. In the next video, we'll take a look at finding the domain of some composite functions.